So here we are with Digestive System II. This one is going to go over kind of more of the accessory organs in a little bit more detail, and also some of the disorders that take place with some of the other parts of the digestive tract. So I'm going to just kind of be listing a lot of stuff that you're going to have to memorize-ish, become familiar with and comfortable with. Yeah, so let's just get started. So again, accessory organs, we talked about the pancreas as being one of them. So the pancreas is an example of one of those glands that is both endocrine and exocrine. And so it depending on what it's secreting or what it's doing, you know, that determines if it's an endocrine function or an exocrine function, because it has the ability to do both. Oops, endocrine. That word is exocrine, even though it doesn't look like that's what I wrote. Okay. So the pancreas has this little duct that goes directly into the small intestine. This organ, the pancreas, is going to secrete pancreatic juice. Okay, and a lot of times they use the word juice. I don't know why, actually, because sometimes they talk about things being a cocktail because it's a mix of a bunch of different things. I guess in this case it's a juice, but it also contains many different types of things in it that are going to aid in the digestion, specifically in the small intestine. So it's going to secrete sodium bicarbonate, which we did talk about with the small intestine, because this is our buffer to neutralize that hydrochloric acid that comes from the stomach. Then we have amylase, which hopefully sounds familiar because this is there to digest carbs. Specifically, it's going to digest our polysaccharide starch. Then we have our trypsin, which, if you recall, continues the protein digestion that started in the stomach. And here's that word lipase I pointed out to you in the last section of this. And this is the one that's going to digest fat, or lipids. Kind of shows you where it gets the name lipase is from lipids. Okay, so the pancreas is also going to secrete some hormones. It's going to secrete insulin and glucagon. So let's do insulin first. So after meal comes in, go away, you little fly. It's there to help store glucose, which then turns into glycogen. And then we have our glucagon, which is going to do the opposite. Glucagon is going to break down glycogen and put it back into glucose so that the body can use it. So if you've been, we'll put fasting, if you haven't eaten for a while, then the body is going to start converting glucagon back into glycogen and then into glucose. Okay. Dang it, I almost had it. Okay, Go away. My gosh. Make sure you can see everything. Okay. And so this little diagram here is just kind of showing you where some of these things are located and the duct that goes into the small intestine. Okay, so next page. Let's talk about the liver. The liver is, of course, a hugely important organ in the body because it has a variety of functions. Sorry guys, let me grab my notes that are trying to fall off the table. Okay, make sure you can see. And at the bottom and on the sides, I think we'll be okay. Okay, liver. So this is actually considered a gland because of the different things that it secretes. So consider it the largest gland. Of the body. It's going to help with the detoxification of blood. And it's also going to store vitamins. So let's look at some of the other things. The liver is going to help to regulate glucose because this is where that glycogen is stored. So remember that after a meal and you have insulin kick in, that's going to help convert the glucose into glycogen. It gets stored here in the liver. And then after a period of fasting or not eating enough, the glycogen that's being stored in the liver is going to be released and converted back to glucose. So that's what we just talked about with the pancreas. Okay. So, without going into all of the details, it is capable of creating some glucose using amino acids. And what amino acids break down into. We kind of go from, where do I want to write this? Amino acids are basically comprised of glucose and then ammonia and carbon dioxide. So when amino acids are broken down, that's pretty much what they break down into. So if needed, the liver can create glucose from amino acids. Okay. So the ammonia part comes in and talking about the urea. This is not urine, it's urea, and this is from the breakdown of ammonia. So if we've got a regulation of glucose because it stores glycogen and can also create glucose from amino acids, so we've got the glucose part, the ammonia is going to be it forms this waste product called urea. And then the liver is also responsible for breaking down old red blood cells. When red blood cells hit the end of their life cycle, they are essentially recycled here. And they're going to break down the hemoglobin that's in the red blood cells and kind of recycle some of the components to be used in the making of more red blood cells. Red blood cells, RBC. Okay. And then we've got the production and secreting of something called bile into the gallbladder. The gallbladder's job is to store the bile, but we'll get there in just a minute. So, bile is kind of this mix of a few different things. Oops, it's like I don't know what that is, comma. Okay, so you've got these mix of things here that are going to make bile, and it helps in the emulsification of fat, which essentially means you have a big fat glob, and after emulsification you have a smaller fat glob. In fact, let's use that big flat glob to a smaller fat glob. It's very scientific language right there, but that's what it is. Okay, so let's look at the gallbladder, making sure you can see. Okay, the gallbladder again is going to store the bile, and then it's going to secrete it into the small intestine. So I'm going to review that here just a sec. Okay, so I don't want you to get confused between where the liver is secreting things and where the gallbladder is. So the liver will make bile, but look where it's being secreted. It's not secreting it into the small intestines, it's secreting it to the gallbladder. And the gallbladder is then going to store it until it's needed, in which case it will secrete it to the small intestine. So it kind of goes liver, gallbladder, small intestine. Okay. All right. Where are most of your taste receptors is the question of the day. And the answer is going to be in your GI tract. And then this is showing a variety of different kind of chemical compounds that are present that kind of determine hunger and to some extent possibly cravings. So there's something here, let me see if I can find it, yeah, in the stomach that actually kind of controls hunger. So this is the part that's going to send the signal to your brain that says, we've been empty for too long, put food in us. And then you can kind of follow that from there through these different cells and chemical compounds that are being monitored throughout the digestive tract, letting the body know if there's something that's lacking, if something needs to be ingested to kind of balance it out, if it's low in salt, if it's low in glucose. So it's the GI tract. Why? Again, is to kind of help maintain nutrient balance and kind of give the signal for hunger. Sorry, hopefully that kept going. Okay. All right. 2 pages. Let's do liver disorders. I'm going to move through it kind of quick. At least to me, it's quick. Not sure how you feel about it, to be honest. All right, so we're going to talk about jaundice. Jaundice occurs because of an excess of bilirubin, which the liver is supposed to break down. But when it isn't breaking it down, it causes this yellowing to take place of the skin and eyes. And we talked about this a little bit, but I don't remember where. I think we talked about it actually, maybe with the red blood cells, because bilirubin is a byproduct of the breakdown of red blood cells, which, as we know, happens in the liver. Let me make sure you can see this. I just kind of started writing on this one. Okay, I think we're good. All right, we talked about this with babies, that babies, newborns, are often experience jaundice. And that's because a lot of times, even when a baby is full term, their liver hasn't started fully functioning yet. And so it's not breaking down that bilirubin a whole lot. And so that can cause them to have some yellow of the skin or eyes. I talked to you, I think, about a little bit about light therapy, natural sunlight, and in more severe cases, a light box that helps to provide the liver with the different vitamins it needs to break down bilirubin. A lot of times jaundice is, at least for adults, an indicator that something is wrong with the liver. If an adult starts experiencing these symptoms, then that's going to call for a liver check for sure. Okay, then we have hepatitis. Hepatitis is a virus most of the time, usually caused by a virus, and this causes inflammation of the liver. There's 3 different types of hepatitis. There's Hep A, Hep B, and Hep C. Hep A usually comes because of, sewage basically that contaminates food. So in recent times, I think we've had a couple of incidents of hepatitis scares. One, I think an employee was infected with it. And another time people became infected because it turns out the employee had used the bathroom, did not wash their hands, and then went and prepared food. And that is how you pass Hep A along. And this can actually be food and water. So like if water has been contaminated with Hep A and then you wash a vegetable in it. Okay, so Hep B is an STD. And it's also easily contracted through needles. So drug addictions that are require an injection easily spread Hep B. So, in other words, drug addicts whose drug of choice requires an injection, and especially if they're sharing needles amongst each other, you easily pass hepatitis B along. So Hep C comes from an individual who is infected, and it comes specifically from infected blood. And this can cause liver cancer and death. So, short story. I used to work for a police department in California. It was like my first job. So really between the years of 18 and 21, I worked for a police department, and it was really cool as a civilian employee. And one time, Geez, how did that even happen? Oh, I was doing a ride along with another officer, and we picked up a guy that had been in a bar fight, and he was bleeding everywhere. I mean, he'd been hit in the face, and he was bleeding from his face and his mouth, and his knuckles were cut out. There was just a lot of blood, and when we got him out of the police car, the back seat was like covered in blood. And even before they found out if the guy had hepatitis, because there was so much blood, even though I hadn't personally come in contact with it, but I was in the car, so it was like just in case, they made a lot of us that had had any contact with this guy go get a bunch of vaccinations for Hep C so that we would not be in trouble if he was infected. Good times. In working in medicine, hepatitis in general is an issue, especially looking at Hep B and Hep C. If you accidentally stab yourself with a needle you've just used on a patient, if a patient is infected and you've come in contact with their blood. So hepatitis is kind of one of those that if you're ever in contact with bodily fluids, for the most part, you gotta pay attention to what you're doing. Cirrhosis. This is when a healthy liver has its tissues replaced with scar tissue. We often think about this as being caused by alcohol. People that basically are alcoholics that drink significant amounts daily. It very quickly destroys the liver because the liver is used to filter out toxins, and alcohol is a toxin that the liver has to filter out. And so the more alcohol you put into your body, the more your liver's having to work to get rid of it, and that eventually causes damage to the tissue, causes scar tissue. However, despite usually being thought of as something that happens with alcohol use, high-fat diets can cause it. Although usually, I don't know, this has to be pretty severe, and there have to be some other factors at play here to have just the high-fat diet cause issues with the liver, with cirrhosis in particular. Okay, let's talk about the large intestine. Make sure we're still recording. Okay, so large intestine, this guy, it's pretty cool because his job is to absorb water and also any leftover vitamins. So again, I've said several times throughout the digestion lectures, different things get absorbed in different parts that it is subtract. We've kind of gone through protein and fats and carbs, where those are largely in the small intestine, but then we get to the large intestine, and now it's going to take water, and it's going to absorb as much of it as it can. It's also going to absorb some vitamins. So the large intestine is then used, all the fun words, to store the waste, solid waste, that will leave the body. Okay? So there's a couple of different parts of the large intestine. We have something called the cecum. It is right here. Okay. The cecum is kind of a pouch-like opening to the large intestine. So this is where the small intestine empties. So everything left from the small intestine after all the absorption from the nutrients, it all just empties now into the cecum of the large intestine. And you can watch it's not apparently going to go through all the different parts of the small intestine, or I'm sorry, the large intestine. But from here you have the ascending colon, and then the transverse colon that wraps across, and then the descending colon. And then we've got this little area here called the sigmoid colon. And then finally the rectum, which leads to all the different anal sphincters. Okay? There's something I was going to say about that, but now I forgot. I cannot remember. So if I do in class, I will tell you, because right now I don't remember what I was going to say. So let's move on to the appendix. The appendix, this is this little outcropping of the cecum, which is basically this. Okay. The appendix kind of holds a reserve of immune cells and also healthy bacteria. Despite this, the appendix, of course, can be taken out with no observable effects in individuals who have had it removed. The appendix can become inflamed and infected, and really the only way to deal with that is to simply have it removed altogether, which today is a relatively simple operation. Okay, so then we're going to look at the rectum. The rectum I've showed you is kind of here. Its job is to compact solid waste. And then I showed you, you can see the anus and anal sphincters. The sphincters are to do what they do every place else in the digestive tract. It's going to prevent backflow. Okay? Very exciting, very exciting. Last page, guys. Look at some of the disorders that can happen with the large intestine. Make sure we can see. Yes. Okay. Here we go. We get to talk about diarrhea again. Who knew that this was going to be such an exciting section? Let's talk about like diarrhea and constipation. And look, hemorrhoids. Who's excited for this? Who's excited for this? Okay. Diarrhea, usually caused by an infection of the lower GI tract. And this can be caused by either a virus or bacteria. This is usually lower GI tract. Either caused by a bacteria or a virus. So the irritation that's caused by the virus and the bacteria as they replicate and invade cells, that irritation causes more peristalsis, so those smooth muscle contractions happen more frequently. By the way, I didn't say this earlier, but peristalsis is something you can definitely feel when you're sick. If you're not feeling good, it feels like your intestines are just tightening. Sometimes it feels like they're tightening unbearably, and that's just these really hard, severe contractions of the smooth muscle in the intestine due to, again, the symptoms or the effects of the bacteria or virus that's invading those cells. So when the peristalsis increases, you actually end up with less water absorption because it doesn't really have the time or the space. Hang on just a second. This is backwards. Yes, I'm sorry. That is correct. There's less water absorption here. And so then when it gets farther down into the large intestine, that's where all of the water is normally absorbed. But because of all the peristalsis, that water's not being absorbed by the small intestine or the large intestine as efficiently, and instead it's just kind of lost as waste or as diarrhea. That's why people, when they're sick with food poisoning or a stomach type flu or something like cholera that causes lots of diarrhea, the concern is dehydration, because you're losing more water due to the diarrhea than you're actually being able to absorb. And so that's why dehydration is always a major concern. Let me see if I can write this. You have to, what do I want to say? I don't know, watch for dehydration, I guess, for lack of a better way to put it. And again, this dehydration comes because you've got less water being absorbed because that water is being released as waste and diarrhea instead. Okay, that was fun. Now let's talk about constipation. Constipation happens most of the time because there's not enough water in the system, and water is super important in the production of, what do I want to say, normal stool or healthy stool. So dehydration will certainly cause this. And when I say insufficient water or like dehydration, I'm not even talking about you've been in the desert for 4 days, and you've only had 2 bottles of water to drink. I'm just talking about on a daily basis. If you drink more soda than you do water, that type of thing is going to cause dehydration. And so you don't have to be dying of dehydration to have this happen. These are just people walking around dehydrated all the time. Also, sometimes a lack of fiber. When we talk about fiber, we're really kind of talking about that polysaccharide cellulose, because it can't be digested. It acts kind of as roughage that sweeps along the inside of the digestive tract and kind of cleans everything out. And so sometimes if you have a really low fiber diet, that can lead to constipation. And basically constipation happens because when there's not enough water, that's not how you spell dries. Dries, D-R-Y-S. I don't know, you guys. I can't spell. I mean, I can, but I can't whenever I lecture. Okay, so it still dries out, and then that makes it very difficult to pass. Hemorrhoids. Let's talk about this, because why not? Hemorrhoids are where you have an enlarged blood vessel or enlarged blood vessels at the anus. Okay, so obviously there's blood vessels that run all through your digestive tract, including at the anus. And hemorrhoids happen because the blood vessels become inflamed, and then that can cause inflammation. It's not uncommon for constipation to cause hemorrhoids. Um, hemorrhoids. So, I mean, I guess they have like some over the counter stuff that can help with symptoms. And for people that deal with them chronically or ones that won't kind of subside, they end up having to be, there's a procedure that I don't particularly want to go into, but basically there's a procedure that's done that pinches off that blood vessel until it dies and the skin around it dies. So, yeah. All right, now let's look at polyps. This is what colon cancer screenings are looking for, a colonoscopy, because you can have normal kind of polyps that are not cancerous, but you can also have polyps that really are cancerous. And again, that's what's being looked at in a colonoscopy. So if the polyps, which are on that outer surface, kind of the mucosa, if those are left untreated, they go deeper. They move into the submucosa. And the submucosa, of course, is where we have all the blood vessels. And so once it reaches the submucosa, it's easy for cancer cells to end up in the blood. Once they end up in the blood, they are moved throughout the entire body. And that's called metastasizing, when cancer spreads through the body. So it's left its original location and has spread to others. And so colon cancer can be fairly easily caught. And usually during the colonoscopy, if they see polyps, they can remove the polyp right there, and then they can check to see if they're cancerous. So that's why I don't remember the ages. I want to say men over the age of 40 and women over, is it 40 or 50 for men? I have to look. I think it's 40. Anywho, blah, blah, blah. You get to a part of life where they really suggest that you have these screenings because it's kind of an avoidable cancer to develop. So again, we've got untreated, goes to submucosa, which has the blood vessels, so then the cancer can easily go to the blood. Just talked about colon cancer screening. Jim Gaffigan has a pretty funny bit on colonoscopies that he did somewhat recently. So, amusing, but I like Jim Gaffigan. Okay, so high-fat diets can increase the chances of having these polyps develop because there's more bile secreted, and that can cause, kind of irritation. And then, yeah, I think that's really all I'll cover with this. So, issues that can happen with the large intestine, and that, sorry, my battery thing keeps coming on. That ends digestion 2 and digestion in general. Nicely done.